So we're going to talk about a little bit more with polynomials and synthetic division, and in particular, how synthetic division lets us find important features in polynomials. So what we saw last class was we can actually do division of polynomials using synthetic division to find out if this divides into that, what will we get? We also use the remainder theorem. So if we use synthetic division, whatever shows up in the remainder spot is going to be the y value that goes with this x value. So in other words, I'm finding a point on the graph using the remainder theorem. We also figured out we could test to see if something was a 0, because if it's a 0, that's the same thing as saying it's an x-intercept. And if it's an x-intercept, which part of the ordered pair would be 0? If I've got a point on the x-axis, the y value is 0. So the way you test to see if this is a 0 or an x-intercept is you do synthetic division. And if you get 0 in the remainder spot, it tells you that's an x-intercept or a 0. If you get anything else, you say it's not a 0. So now we're going to look at this, and that means that if I want to find zeros, okay, it would have to be true that x minus some value of k, as long as I get 0 in the remainder spot, that tells me that x minus k is a factor. So that happens if and only if f of k equals 0. All right? Now, I got to determine whether x plus 4 is a factor of this polynomial. Here's the only thing different from what we did at the end of section 2. That was, they told us use k equals some number. We're going to have to make the adjustment here and find k before we do the division. Okay, so if I want to know if x plus 4 is a factor, what number am I going to use for my divisor? Excellent, because we said anytime that it's following the x, we have to change the sign of it. So in other words, we want to know if negative 4 will divide in and give us 0 in the remainder spot. Now let's look at our function and see if you can tell me what we should write for our row of coefficients.
3. 0.
Excellent. Do you see why we need a 0? What's missing?
X cubed.
Yeah, there's no x cubed term. So we have to have a 0 as a placeholder. Then negative 48 and
32.
Good job. Okay, I'm going to draw the line, leaving a space. Start by bringing down the 3. Good. So what goes under 0? Negative 12. And if I add those together, I get negative 12. Now what's going to go under negative 48?
48.
Good. A negative times a negative is a positive. So that's positive 48. And when I add those together, I get
0.
Now don't stop here, because the fact that I got 0 here doesn't tell me anything about whether or not this is going to be a factor. I've got to go all the way to the end. So that means when I multiply 0 times negative 4, I get 0. And 8 plus 0 is 8. And now when I multiply 8 times negative 4, I get good. So that gives me 0 here. What does that tell me? So yes, because this is a 0, it means x plus 4 is a factor. Okay? So not only can I find zeros, I can determine if something is a factor, if it divides in evenly. Okay, so on B, I want you guys to do that yourself.
So does that mean that that's the x?
All right, so tell me what you wrote for your row of coefficients.
1, 6, 11, 12, 5, negative 20.
That was just like a beautiful choir. I love it. All right, so you brought down the 1, and that meant what went under 6?
Negative 4.
Yes, and if I added those together, I got 2. So what goes under 11?
Negative 8.
Yes. And if I add those together, I get,
3.
and what goes under 12?
Negative 12.
We've got another place where 0 occurred in the middle, but I don't stop. I got to keep going. And 0 times negative 4 is 0. So when I add those, I get
5.
5. So what belongs under negative 20?
Negative 20.
And if I add those, I don't get 0. I get what?
Negative 40.
That one is darn sneaky because you're tempted to want to say, oh yeah, those will cancel out. They don't because they're the same sign. So it is not a factor. All right, now here is where you're going to start finding how to factor polynomials. Because if I know a factor, I can find the other factors many times because now I know how to do it using synthetic division. So we're going to start to put together different tools in our toolkit so we can find the things we're going to need to get these polynomials graphed. So if I tell you that 5 is a 0 of this function and I want you to factor it for me, how do you think you would start? First of all, if 5 is a 0, what should happen if I use synthetic division and I use 5 as the divisor? What should I get for the remainder? I would say let's start there, because if I do that and I don't get 0 in the remainder spot, I've got 2 options. I've either made a mistake or they've lied to me. Let's find out if it works. So tell me what the row of coefficients should be. 6.
Negative 37.
Uh-huh.
32.
And 15. Very good. All right, so we're going to bring down this 6. And what goes under the negative 37? 30. So if I add those, that's a negative 7. And under 32, I have, so when I add those, I get negative 3. And negative 3 times 5 is negative 15. And that's good. I did get 0. So I feel pretty confident that I've done it right, and 5 really is a 0. Now, the problem is I'm trying to factor. This is what I have left. What would it look like if I put the variables and the exponents back in? This would be 6x squared minus 7x minus 3. Now, do you have any idea how to factor that? We can use the AC method. Remember, we did this back in chapter 1. So this is quadratic. You just factor using quadratic techniques. If you want to open up 2 parentheses, kind of guess and check until you get it, that's fine. If you don't remember how the AC method worked, I'm going to jog your memory here just a little bit. So remember, the A value is the coefficient in front of x squared. C is going to be whatever the constant is. So using the AC method, if I multiply 6 times negative 3, I get negative 18. All right? So I need a pair of numbers that will multiply to give me a negative 18. My B value is what? Negative 7. So my pair of numbers should also add to give me negative 7. Now, talk to me about signs. If I'm multiplying 2 numbers and I get a negative, what do you know about the signs?
Well, they're different. One's
They're
positive,
different.
one's negative.
One's negative and one's positive. What would be the right pair of numbers to make this work? Very good. A negative 9 and a positive 2 will do both of these things. Multiply to give me a negative 18, add to give me a negative 7. Now, that's not what goes in my parentheses, but that's what I could replace this middle term with. Remember, if the A value is not 1, you may find it easier to use this method to get this factored. It's totally up to you, but I'm going to replace this negative 7x with a minus 9x plus 2x minus 3, and now I'm ready to pull out the greatest common factor of each pair. So when I look at the first pair of numbers, or the first terms, first pair of terms, what would be my common factor, my GCF? Good, I can factor out a 3x, and in parentheses I'm going to have what? 2x minus 3. Excellent. Bring down the sign in the middle. It's a plus sign. And if I look at the last pair, what's the GCF? 1 is the only thing that goes into both of those. I still have to write it down. And in parentheses, I will have my 2x minus 3. Now, the reason for doing this is I'm hoping what matches. Yeah, as long as I did this correctly, these parentheses should match. And I'm using, pulling out the greatest common factor again. So this thing is ready to be factored into 2 parentheses. And we end up with 3x plus 1 in one parentheses, 2x minus 3 in the other. What I'm doing is factoring the original function, but be careful. These are the 2 factors that came from here. What is the other factor that I better not forget to write down?
0.
They gave me a 0. The 0 was 5. Can you put it back in a parentheses with the x? What would it look like as a factor? Remember, it's kind of going the opposite direction from what we did up here. They gave us the factor. We figured out from the factor what needed to be the possible 0. Okay? They're giving us the 0. We need to put it back in a parentheses after the x. So yes, the sign changes when it follows x. So I also need a parentheses with the x minus 5. That is how you would factor this cubic function. So we're able to go both directions here. We can take factors and see if there's zeros, but we can also take zeros and turn them back into factors. And could I check this if I wanted to be sure it's right? Yeah, if I want to use FOIL and take that answer and then multiply it times the other parentheses, I could check it, but it will be right. Okay? Now, as long as I've told you a 0, that's a pretty easy way to get things factored. But I want us to back up a little bit. I'm going to modify the way I usually teach this because I'm pretty sure I'm going to have to change this for future classes. So I'm going to go ahead and change it with you guys. We're going to talk about something called the rational roots theorem or the rational zeros theorem. This came about because I want you to think pre-calculator days, okay? And the problem is, if I gave you something that looked like this, 8x to the 4th minus 26x cubed minus 27x squared plus 11x plus 4, and I asked you to factor that thing. Since we now know if something is a 0, when I use synthetic division, I should get a 0 in the remainder spot. Do you think you could maybe find zeros? Do you think it would be easy? I mean, think about it for a minute. Would you, if you're just, it's kind of like looking for a needle in a haystack. If you're randomly guessing numbers, I mean, you could do an awful lot of numbers before you actually stumbled onto one of the zeros. So there was a little tool developed that helps you narrow down the possible zeros that this function could have. And that's the rational zeros theorem. Now here's how it works. If P is a rational, or P is going to be the factors that you would have when you factor out the constant term. Now the constant term, if it's in descending order, is going to be your very last term, okay? And Q will be all of the factors that you would have for the leading coefficient. In other words, the first term, the coefficient in the first term. And we would have to write all those out. Once we have those written out, we're going to make ratios. And whatever we end up with will be the only possible zeros that exist. Now, it doesn't mean that they're all zeros. In fact, many of them won't be. But it gives us a smaller pool of things to test using synthetic division until we find the zeros. Now, I'm going to be real honest with you guys. Usually, at this point, I tell students, I'm going to show you how to do this because you may have an instructor one day that expects you to use this. Would you mind closing the door for a second, Carlos? And I will say, like if anybody goes to UT Tyler and you're going to have to take math classes there. I don't think UT Tyler lets you use calculators at all, which is kind of mind-boggling to me because there are some things I really don't know how you would do without a calculator. But maybe they provide certain tables or some kind of information for you. So what I'm going to tell you is in this day and age, with the tools we have available, there are faster, easier ways to come up with a zero to help you get started on this. I'm going to show you how you can do it by hand though, all right? And the way you have to do it is this. I'm going to write out all of the different factors of 4. So if I were to ask you, what are the possible numbers that divide into 4 evenly? What are you going to tell me?
1, 2, 4.
1, 2, and 4. Now, is that all of them? Okay, I hear no. Why not?
0.
Well, 0 won't divide into, I mean, 0 is not going to be a factor of it because I can't multiply 0 times something to get 4. But what else? You got it. There is both positive and negative of these values that will be factors. That's actually 6 different numbers that you have as factors for 4. Now, Q is the number 8. What are going to be my possible factors for 8? 1, 2, 4, 8, and they all can be positive or negative, right? Now, think about this for a minute. We got 6 different values for P. We have 8 different values for Q, and we've got to put all those together to make all the different possible numbers you can get when you try to make fractions out of that. It's a whole lot better than randomly guessing, but it's not going to be a small list. And 4 and 8 are pretty small numbers. What would happen if this was like 32 and this was 64? I mean, you can see where this is not terribly efficient in the big picture. I have actually seen students who've had to spend maybe 1 hour just coming up with that first factor. Because you may have a list that's so long that it takes a while before you find one that works. So let me just kind of work you through this. If I want to make these fractions, let's start with the 1 for P. So if I put plus or minus 1 on top, then when I divide through by everything that I have here for Q, I've got plus or minus 1 over
1.
Yep, 1 over 1. In fact, I'm just going to do it this way because that one won't be a fraction. But when I come over here, I get plus or minus 1 over 2. And again, because there's I just need the plus or minus in one place. I don't want to put it both top and bottom. I'm going to have plus or minus 1 over what? 4. Plus or minus 1 over 8. Now, that looks like that's going to be fun. Those are all fractions. All right, let's see if we get into better shape with some other numbers. Let's go to plus or minus 2 now. So plus or minus 2 over 1 is just plus or minus 2. What happens when I do plus or minus 2 over 2? And I already have that one listed. So I got a repeat. I don't have to write it down if I've already got it listed. What's plus or minus 2 over 4? And I've already got 1/2. And 2 over 8 is 1/4, and I've already got that. So I don't have to write it down again. But let's move over here to 4. And I get plus or minus 4 over 1, which is plus or minus 4. That's a new one, okay? But what happens if I do 4 over 2? I get 2. And I already have 2. And 4 over 4 is 1, and I already have that. And 4 over 8 is 1/2, and I already have that. Now, let's count up. How many different numbers do I have here? 6. There are 6, but they all have both either positive or negative. That's 12 different numbers that I can try until I find my zeros. All right? And at this point, it is kind of a random guess. So if I were to ask you to try to use synthetic division to see if we can get this thing factored, first of all, give me the row of coefficients. You're going to write down 8. Good. Now, my hunch is you might not want to start with fractions. Am I right? Okay, so let's pick either positive or negative out of 1, 2, or 4. What do you want to try? And it's pretty much a random guess at this point.
2.
All right, positive?
Yes.
So let's see what happens if we use positive 2. All right, let's bring down the 8. So what goes under negative 26? And if I add those, I get, so what goes under negative 27? And if I add those, I get, okay, now I'm looking at this. Is this looking promising? There may be a point like this where I can see, okay, that's going to be like a negative 94. There's no way I'm going to get there. Throw that one out. Pick a different one. What do you want to try now? Positive 4. So let's try positive 4. Bring down the 8. 8 times 4 is 32. And if I add those together, I get positive 6. Okay, 4 times 6 is, and if I add those together, I get, and 4 times negative 3 is, and if I add those, I get negative 1. This is looking promising because what's 4 times negative 1? And negative 4. And 4 plus negative 4 is, whoop, whoop. Okay, we just found one. That's exciting. So I know that 4 is going to be a 0, which means I now have a factor, which would be x what? Minus 4. Now, if I were to put variables and exponents back in here, what would this thing be?
X here.
Yeah, because I started with x to the 4th. That means this is an x to the 3rd. Oh my goodness. I don't know how to factor when it's x to the 3rd. I got to get down to something that's quadratic before I can do something else. I've got to stay with my list and see if I can find another 0 that would go into this before I can try to just factor using quadratic techniques. Does that make sense? So we've already tried positive 2 and positive 4. Let's pick something else. What else do you want to try? Let's see what happens if we use negative 2. And so I can just use this row of numbers right here and try to divide in negative 2. So if I bring down the 8, 8 times negative 2 is, and 6 plus negative 16 is negative 10. If I multiply negative 2 times negative 10, that's 20. Yeah, this isn't looking good because that's a negative 17, and that's not going to give me a 0. So that's not going to work. Now remember, this is the row I'm working with now. 8, 6, negative 3, negative 1. So I'm going to come over here. 8, 6, negative 3, negative 1. 2's aren't working, so what do you want to try now? Why don't we try negative 1? So if we use negative 1, we get an 8 here. Negative 1 times 8 is negative 8. So if I add those, I get 2. And it's negative, isn't it? Negative 2. And negative 1 times negative 2 is positive 2. Negative 3 plus 2 is negative 1. And what's negative 1 times negative 1? 1. Oh, praise the Lord. We just found our second one, which means we're going to get what else as a factor? X plus 1. Because remember, when it goes in the parentheses after the x, the sign changes. Now if I put back in variables and exponents, this is an x squared. That's going to be minus 2x minus 1. And I'm ready to factor this. Now, I'm going to give you a little shortcut here on factoring. You can use the AC method. I'm just going to go ahead and tell you, if you factor this, I'm going to get a 4x here and a 2x here, and the only way I can multiply two things together to get 1 is with a 1 and a 1, but because there's a minus sign there, I know I need a plus sign in one parentheses and a minus in the other. Which sign belongs here?
Negative.
Actually, this one should be the plus and this one should be the minus. And here's how I'm going to double check all this. I'm going to use FOIL. 4x times 2x, that's 8x squared, right? What is 4x times negative 1? Negative 4x plus a positive 2x is how I get a negative 2x, and a positive 1 times a negative 1 is a negative 1. You can use the AC method, but I just went ahead and factored it this way. Now remember, I'm trying to get this factored. Do I now have my other two factors that I need? Yes. If I wanted to find zeros, could I also set these parentheses equal to 0 and come up with what the zeros are? Yeah, this is where the fractions are going to show up. I'm going to get a -1/4 and a +1/2. So the good news is, if you have fractions up here, probably you're also going to have some whole number values that if you do synthetic division, you can work your way down to something that would then be able to be factored with quadratic techniques. That's the rational zeros theorem. Now, I will tell you when you test, hang on a second, and we will look at this statement before we turn the page, which says the rational zeros theorem gives only possible rational zeros. Remember, we don't know if these are actual zeros. We discovered there were a couple of them in our list that really weren't zeros. And what do you have to do to figure out if they're really zeros or not? Use synthetic division. You're right. Now, the fundamental theorem of algebra says every function defined by a polynomial of degree 1 or more, if it's first degree, it means there's a variable there, x to the first in it, has at least one complex zero. Okay, now that word complex tells us what is in the number. If it's a complex number, you see, well, we do see real numbers. That's part of complex numbers. But if it's complex, if it's non-real complex, what do you see in the number? What makes it complex? Oh my goodness, I, right? That imaginary number I? Yeah, way back in chapter 1, complex numbers. So what this is saying is we've been working with all the real numbers, finding the real zeros. This is just a reminder complex zeros also exist. Now, before you freak out, I'm not going to make you find those. I'm just going to tell you that you could, okay? You could find them. And here's the other thing that's kind of important to know. A function defined by a polynomial of degree n, so whatever the degree is, that means it's the largest exponent, will have at most n distinct zeros. So in common terms, here's what that means. If you're working with something that's cubic, so the biggest exponent is 3, what's the most number of zeros you can have? 3. The one we just did had x to the 4th. So what was the largest number of zeros you could have? 4, exactly. You'll never get more zeros, real zeros, than what the highest exponent is, okay? So now we're going to kind of go in reverse direction, and we're going to be given zeros and see if we can come up with a polynomial that satisfies these conditions, okay? So I have zeros that are at -3, -2, +5. And then they tell me this, f of -1 equals 6. And I'm supposed to come up with the polynomial that would meet all these conditions. So let me just kind of give you a little, hopefully, picture of what's going on here. So if I were to picture this thing, and it tells me these are where my zeros are, I would know it crosses the x-axis at -3, it crosses the x-axis at -2, it crosses the x-axis at +5. And then what does this mean when it says f of 1 equals 6?
At -1 and 6.
Yeah, so here's the deal. I could know one other point. If I didn't know this point, wouldn't you agree there's a bunch of different ways I could try to connect these? If I have these zeros, it means it's got to be crossing the axis there, and this thing could kind of just start from the bottom, come up a little bit and turn and go back this way. It could also start from the top, and it could come up and go back that way. I really don't have any clue what this shape would be as far as where does it start, what does it do, unless I also have this extra point, and then I'm going to learn some other things about it. So here's what we will do. We cannot use synthetic division because I don't have the polynomial. That's what I'm looking for. Since I know these are zeros, I can write them as factors, but here's the problem with not knowing how these things get connected. Do you remember when we had vertex form for the quadratic equation? The a that's in front of the parentheses squared was what told us if we had a vertical stretch or a vertical shrink. It also told us whether it opened up or opened down based on whether it was a positive number or a negative number. That's the missing part. I don't know on this thing because it's going to make a difference. If there is a number in front of all these factors, I'd need to know what it is in order to know how this graph needs to look. And that's why this point is very important. It's going to be able to help me find if I've got a vertical stretch or a vertical shrink and whether this thing reflects over the x-axis or not. So here's the tool we need. We want factored form for a polynomial. And since there are 3 zeros, we're going to write this as f of x equals a, because that's what I don't know, is the vertical stretch, shrink, or reflection. But I'm going to take these zeros and I'm going to write them out as factors. So what goes in the parentheses after the x? X plus 3, because remember the sign changes when it follows the x. And then I have a parentheses that has, and I have a parentheses that has, very good. Now, if I knew what a was, I'd be done. That would be my equation for the polynomial. But I don't know it, but I have a piece of information I haven't used yet. What is it? F of negative 1 equals 6. Now, tell me in layman's terms what this actually means. The negative 1 is what kind of value? That's an x value. And it's saying if I use negative 1 for x, 6 is my, you got it. Couldn't I plug negative 1 in for all of these x's? And then what can I put in for f of x? That's it. That's why this point is very important. It's going to let me solve for a, because that's now going to be the only thing I won't know. I can put in negative 1 everywhere there's an x. And now I've got actual numbers that I can find when I clean up these parentheses. What is negative 1 plus 3? 2. Negative 1 plus 2 is 1. And what's negative 1 minus 5? Negative 6. Negative 1 minus 5 is a negative 6. So let's multiply these together. 2 times 1 times negative 6 is what? Negative 12 times a. And now, if I divide both sides by a negative 12, what do I get for a? Negative 1/2. Now, I don't stop there because remember, I'm supposed to find the function. I'm supposed to write out what f of x equals. But what can I do with a equals negative 1/2? Exactly. I go back up here, and I'm going to replace a with negative 1/2. And I get f of x equals negative 1/2 times x plus 3 times x plus 2 times x minus 5. And that would be the equation that would satisfy those conditions. It has those 3 zeros and it passes through that point. Now, I'm going to give you a heads up. Your homework in my math lab, when you get to this, I believe one of the questions is going to ask you to write the answer in standard form. Now, standard form means you would have to do what with all these parentheses? Multiply them out and turn it into something x to the third plus something x squared, and combine all those terms. I am not going to ask you to do that. I mean, I have some students who say, I don't care, I'll just go ahead and do it. And they multiply it all out and type it in. What I am going to tell you is, if you type your answer in factored form like this, and you hit check my answer, you're going to look at what the response is. Because if it says, although your answer is correct, it is not in the correct form, that tells you you did it right. So that's all you need to check and see is, does it tell me that? At that point, what I'm going to tell you you can do is hit the Ask My Instructor button from that problem, and that'll start an email to me, and you just need to say, check this please, and I will manually go in and give you credit, so you don't have to spend your time multiplying it all out. I think there's another question that it lets you leave the answer in factored form. So if you run into that and you're getting that message, remember, just send me an email and I'll fix it for you, okay? So let's do one more, and when we finish with this, we'll be done. This has some phrasing that looks a little funny. It sort of makes me think about the commentators on sports programs now. You know, if you went back 20 years, you would never have heard the word physicality. Okay, they have made up new words when they start talking about these athletes. And physicality is one of them. You may think the same is true when you see multiplicity, because it kind of sounds like it's in the same vein. But what would you think multiplicity means? How many times something occurs. So if something occurs with multiplicity, it occurs more than once. So this says 4 is a 0 of multiplicity 3. What does that mean? It's a 0. 4 is a 0 how many times? 3 times. That's exactly what it means. So what you might want to do is just write 4, 4, 4. Just so you'll remember, multiplicity is just telling me how many times it's a 0. So help us get started here. If we go back to what we were doing, my function is going to equal, what would I need to write first? Yes, because I've got to find if there is a stretch or shrink or reflection. And then what do you write?
X minus 4, X minus 4.
Very good. X minus 4, X minus 4, X minus 4. Okay. Video up and then we'll go. So what you guys did is you were able to plug in 2 for X and negative 24 for Y. And that meant you got this. And each one of these simplified to be a negative 2. So when you multiply negative 2 times negative 2 times negative 2, that gives you what number?
Negative 8.
Yes, a negative times a negative times a negative is still negative. So that's a negative 8 times A. And when you divide both sides by a negative 8, a negative divided by a negative is a positive. So A was equal to positive 3. Now, when you write the function, remember, that's not where you stop. You're supposed to be writing the function that would satisfy these conditions. So f of x would equal, and we'll put in 3 for A. And then Courtney had a good question. She said, can you just write this with an exponent? And the answer is yes. If you wanted to write x minus 4 and then put the exponent of 3 on it, you can do that. If you want to write it out with 3 parentheses, that's fine too. All right, so we have finished section 3.